Okay, so let's look now at graphing linear sequences. We've already looked at identifying a linear pattern by determining if the number between each stage is the same or the first difference is the same, but now we're going to look at how we graph them. So here we have a pattern of numbers 1, 4, 7, 10, and 13. And first of all, I'd like to establish, is it a linear sequence? Well, if we look, we can see the difference between any two numbers, or the first difference, as it's called, is equal to 3. So each time they go up by the same amount. So this will help us now get the general term of our pattern. It's going to be the difference 3 times a variable. I'm going to call it S. In Scott's class, you called it B for blocks, but guys, seriously, get over it. It's just a letter. It doesn't matter. It's the exact same thing. I say S for stage. Miss Scott says B for block. You could use N. It doesn't matter. So anyway, 3S. And we're going to see if that's enough. Well, if we look at our first stage, we get 3 times 1, which is 3. However, the first number in our pattern is 1, not 3. So to get 1, we'd have to go 3 times 1, 3 being our difference, 1 being, because it's the first stage, the first number, minus 2 is going to give us 1, which is correct. Now let's look at the second stage, 3 times 2. Well, that's equal to 6. However, the second number in our pattern is 4, not 6. So we're seeing the same thing again. 3 times 2 minus 2 is equal to 4, which is correct. Now we're going to look at then the general term. It's going to be 3s minus 2. Capital S, yet again, doesn't really matter. So with this equation here, I've got a general term or general formula for any number in this pattern we have here. I could find any term. Just know what stage number I want to find and replace it with an S, okay? But how do we graph this? Well, it's actually quite easy, okay? Think of it like this. If I put it in the form of a table, okay, where we've got our stage number and our value, okay? Stage 1 was 1, stage 2 was 4, stage 3 was 7, stage 4 was 10, stage 5 was 13. Well, what we have here now, folks, is coordinates. We have our x coordinate and we have our y coordinate. So I can group these together as coordinates. 1, 1, 2, 4, 3, 7, 4, 10, and 5, 13. And we can now take these values and we can graph them. So let's go into our graph. Now, I'm using GeoGebra here because I'm obviously working from home. What number should I label my axes? Well, the biggest number on the y side, the value, the biggest number in the pattern is 13. So I want to go to at least 13. Honestly, I'd probably go up to 14, okay? And then on the x-axis, 1 to 5. So this is fine. Now, obviously, because I'm using a computer, I can't see where 13 is exactly. But because I'm using GeoGebra, which is freely available to download, and you should do it, I can type in the coordinates. So the first coordinate is 1, 1. Our second coordinate was 2, 4. Our third coordinate was 3, 7. And already we're seeing, folks, a straight line here, okay? Our fourth coordinate was 4, 10. Once we have 3 points, we can confirm if something is a straight line or not. The books often will tell you, our last coordinate, 5, 13, that you only need 2 points to draw a straight line. As I've always said to my students, that's not enough. If I have 2 points, I don't know if it was right or not. I could have made a mistake. Now we're going to simply draw a line and we are going to connect the dots. And you'll note, look what's going on here, folks. The line cuts through the point -2. In my general equation, 3s minus 2, well look, the -2 here refers to this -2 right here, okay? And let's look at this, okay? Let's see if we can see this equation here. We have -3x plus y is equal to -2. Well, if I use stabilizers on this equation here to get the -3x over to the other side, I would have y equals 3x minus 2. Or, as we have here, my pattern is equal to 3s minus 2. It's the same equation, folks. Remember what I said to you already. The letter doesn't matter. This is the same as this. We could always try and find the slope of our line as well if we wanted, and that would help us as well. Okay, so this is how you would graph a linear sequence. It's that simple. Okay, I hope this makes sense. If you have any questions, send me an email. If you're not sure, look through the examples. Well, actually, I don't think there are any examples in the book, but look through this video again and let me know if you're still not quite getting it. Okay? So